China did not publish an ordinary update. It delivered something far more unsettling, a verdict. There was no dramatic press conference, no countdown, no polished announcement designed to stir excitement. Instead, the revelation arrived quietly, almost invisibly, through a routine upload of FITS files, photometric readings, astrometric positions, and time-stamped data streams that slipped into national archives like standard paperwork. But the scientists who opened those files did not see routine measurements. They saw confirmation. They saw the one possibility astronomers across the West had been hoping they would never be forced to confront. Because China's new observations of 3I, Atlas, captured during the most suspicious 36-hour blackout in Western astronomy, did not simply fill in missing data. They rewrote the entire story. They showed an interstellar object brightening when it should not have brightened, expanding its coma in ways current models struggle to explain, forming a tail structure that contradicted earlier readings and behaving with a level of precision no natural comet should display. And the strangest part was this. Nothing about the object itself seemed to change, and yet everything changed around it, as if 3I, Atlas, was not waiting for solar heat at all, as if it had been waiting for us, waiting for that gap, waiting for the exact moment when only one nation would be watching. In a case like this, the timeline is everything, and the timeline is where the real problem begins. On the 1st of July 2025, Chile's Atlas survey first detected the object that would later be named 3I, Atlas, only the third confirmed interstellar visitor ever recorded by humanity. But from the moment astronomers began calculating its orbit, something about it felt wrong. It was not merely fast. It was too fast, moving at heliocentric speeds near 209,000 kilometers per hour, crossing the solar system on a path that clearly did not belong to our Sunday. Western observatories immediately directed enormous resources toward tracking it. Hubble, the James Webb Space Telescope, the Very Large Telescope, Gemini major instruments across the world were aligned to build a continuous record of its motion and behavior. And then, right at the most sensitive phase of the object's development, the entire system went dark. Not because of weather, not because of a random technical failure, because of schedules. For 36 hours, 5 major Western observatories were offline at the same time. One was undergoing gyroscope realignment, another was handling mirror cleaning, another had an instrument swap planned, others cited maintenance cycles and mission reprioritization. Taken one by one, each explanation sounded ordinary. Taken together, they looked almost impossible. In that narrow window, that tiny slit in the fabric of global astronomy, 3I, Atlas, moved dangerously close to the sun's glare. That was the exact period when a comet reveals the truth of its structure through peak outgassing, jet activation, coma expansion, dust-to-gas ratios, and the stress fractures of its nucleus. That is when astronomers learn what an object really is. A natural comet would have nothing to hide in that moment. An unnatural one would have everything to reveal. The West closed its eyes. China did not. While Western observatories went silent, China's high-altitude stations in Tibet, Qinghai, and Yunnan stayed fully active through the blackout. There were no maintenance pauses, no scheduling conflicts, and no instrument transitions. The skies over that hemisphere were dark, stable, and perfectly positioned for uninterrupted tracking. So while some of the most advanced observatories on Earth stood still, China kept watching. And what it captured was not a few scattered images or partial measurements. It was a continuous stream of astrometric positions, coma expansion rates, tail morphology, multi-filter photometry, dust grain size distributions, and brightness evolution curves, all time-stamped with millisecond precision. Every exposure passed through cooled systems operating under sub-zero night air. Every FITS file moved through redundant fiber optic links into data centers in Beijing and Nanjing. And what those instruments recorded was not what Western scientists expected to find when the blackout ended. The coma did not merely expand, it expanded sunward. The tail did not simply appear. It lengthened at a rate that looked unnatural. The brightness did not wobble within expected variation. It increased by 0.3 magnitudes in only a matter of hours. The dust profile did not drift in a way astronomers could easily dismiss. It shifted toward larger carbon-rich grains, something almost unheard of for a comet with this apparent chemical history. China did not just fill a data gap, China exposed the importance of that gap. To understand why that matters, you have to understand what a coma is. A coma is the cloud of dust and gas released when a comet is heated as it approaches the Sunday. It is supposed to be the visible sign of ordinary activation, a frozen body waking under solar radiation. But 3I, Atlas, did not look like it was waking up. It looked like it was reacting. It looked like it was responding. It looked like it was speaking through particles. By mid-July, before the blackout, both JWST and SphereX had already noticed something unusual. The coma appeared dominated by carbon dioxide rather than water, a signature that points to a thermal history unlike that of comets native to our solar system. Then, during the blackout, at the very moment solar radiation peaked, China recorded something even stranger: a brightness surge, an expansion wave, and a structural rearrangement in the dust cloud itself. It did not resemble random sublimation. It resembled a pattern. And patterns like that can only be caught if someone is watching constantly. China was. The West was not. When JWST and the VLT finally returned online, the time series had been broken. During those missing hours, the comet had traveled roughly 1.2 million kilometers, more than enough to blur any attempt to reconstruct the event in high detail. But China's data stitched the sequence back together as if nothing had been lost. When scientists aligned the coma readings into one continuous progression, the conclusion became difficult to avoid. This interstellar visitor was not behaving like a comet, simply trying to survive a close solar encounter. It was behaving like an object reacting to that encounter with speed and coherence far beyond expectation. And once that possibility entered the conversation, the story changed completely, because now the real question was no longer what 3I Atlas was made of. The real question was whether it was acting according to physics alone or according to something far more organized. This is the point where the story becomes even more unsettling, because the most important details do not sound dramatic at first. They sound technical. Every photon China captured passed through nitrogen-cooled CCD detectors, atmospheric correction pipelines, redundancy servers, checksum verification, metadata alignment using Gaia DR3, and light curve cross-calibration against standard sequences. In plain terms, this was not rough observation. It was precision astronomy at the highest level. And while Western observatories with mirrors several times larger were recording nothing at all, China created the first continuous photometric sequence of an interstellar comet during peak solar activation. That sequence showed coma elongation toward the sun, photometric brightening consistent with jet activation, dust ratios incompatible with water-driven sublimation, a nucleus brightness profile that did not match estimates, placing the object at only around 300 meters in size, and astrometric precision good enough to reduce orbital uncertainty by a factor of 5. This was more than competent science. It was strategic science. And in that strategy, China recorded the exact moment Western astronomy missed. By the time Western systems came back online, the damage had already been done not to the object, but to our understanding of it. A fast-moving interstellar body passing through perihelion progression cannot afford a 36-hour blind spot. That is not a simple gap in observation. It is a wound in the record. Without China's logs, the West would have awakened blind to the sudden asymmetry of the coma, the sunward jet structure, the brightness surge, the change in dust-to-gas ratios, and even the subtle shifts in trajectory. But perhaps the most troubling part was what happened after Western models were updated with the new data. Even then, the object still refused to fit natural comet behavior. The missing section of the light curve had left uncertainties too large to ignore, and every recalculation pulled toward the same conclusion. Whatever 3I Atlas was, it was not acting like a comet randomly ejected from another star. That may explain why the silence from Western agencies became so loud. NASA, ESA, NORLAB, none of them could easily deny what China could now demonstrate, and when China uploaded the blackout period files to the China VO Sky Survey portal, astronomers across the world saw the data before any official commentary was released. There was no interpretation attached, no dramatic framing, just raw files and raw measurements, the most honest form of truth science can provide. Within 12 hours, the Minor Planet Center recalculated the orbit. American institutions downloaded the FITS datasets. European analysts ran their own photometry. Orbital uncertainty collapsed from 25 arcseconds to 5. The hyperbolic nature of the object's path was confirmed with extraordinary precision. But the strangest details still remained. The coma's elongation was not random. It had direction. It had consistency. It looked less like noise and more like a response pattern triggered by solar radiation. And when the documents referred to an echo signal that was not poetic language, it described something literal. 3I. Atlas reacted to sunlight, as if it anticipated sunlight. Once Chinese and Western observations were merged, the impossible happened. Spheric spectra, Hubble brightness profiles, China's BVR coma geometry, Gaia DR3 astrometry, scattered light dust models, nucleus size limits, and revised orbital calculations all aligned into a single coherent timeline. And that unified timeline pointed in only one direction. That timeline showed a carbon dioxide dominant comet that should not behave the way this object behaved. It showed a brightness curve inconsistent with its thermal history, a tail structure that shifted during the blackout hours, a nucleus too small to generate the observed coma by natural means, a dust-to-gas ratio far outside the norm for our solar system, and an object that responded to solar activation faster than current physics predicts. This was no longer a story about a random rock from another star. It was a story about a phenomenon. And China's observations did not claim alien technology, did not promote conspiracy, and did not rely on speculation. They simply showed the thing the West had tried hardest not to face. 3I. Atlas behaved differently during the exact period when only one nation was watching. It brightened when others could not measure it. It altered its tail structure when only one hemisphere had a clear view. It expanded its coma in a direction that natural models struggled to explain. It responded to sunlight in a way that resembled activation, not simple melting. And every layer of data aligned too cleanly to be dismissed as coincidence. The true fear was never that the object was dangerous in the simple sense. The deeper fear was that it appeared deliberate, coherent, and purposeful. That is what China's discovery confirmed. This was not just an interstellar object, it was an interstellar event. And whatever 3I Atlas truly is, it seems to know how to hide, and even more disturbingly, it seems to know when we are not looking. In the end, it was not the telescopes, the images, the brightness spikes, or the impossible coma expansion that shocked the scientific world most. It was the silence in the West, and the data from the East that broke it, because China did not merely observe something strange. It observed something the rest of the world was not supposed to see, something that slipped into the blackout window, changed its behavior while Western observatories were blind, and emerged from that interval looking nothing like the object scientists thought they understood. For months, astronomers insisted that 3I Atlas was simply a comet, a frozen traveler from another star, and nothing more. But comets do not react selectively. They do not redirect coma structure during the exact hours when half the planet is blind. They do not brighten on cue, alter dust profiles only when observed by a single nation, or mimic activation patterns precisely when solar radiation peaks. China's discovery did not create fear. It confirmed the fear already sitting beneath the surface. It confirmed that the visitor we treated as passive may not be passive at all. It may be ancient, it may be harmless, it may be something stranger than either of those words can hold, but it appears to carry intent. And that is the truth now hanging over this entire story. We did not just detect an interstellar object, we may have detected interstellar intent. If this story made you question what really entered our solar system, stay with us. Subscribe, turn on notifications, and tell us in the comments, do you believe 3I, Atlas, is just a comet? Or could it be the first interstellar system humanity has ever watched in motion?